good evening. Welcome you all for today's session, DC characteristics of op-amp. So here we are going to discuss about two characteristics. One is DC and another one is AC of ideal op-amp. So the ideal op-amp, first of all, why we are going for DC characteristics? An ideal op-amp draws no current from the source and its response is also independent of temperature. A real op-amp does not work on this way. The current is taken from the source into the op-amp inputs. So the inputs respond differently to current and voltage due to mismatch in transistors. So a real op-amp also shifts its operation with temperature. In this case, these non-ideal DC characteristics that add error components to the DC output voltage. So this is the reason why we are preferring DC characteristics. So what are all the DC characteristics here? There are four characteristics. One is input bias current, and second one input offset current, third input offset voltage, and fourth thermal drift. So the first one is input bias current. The op-amp's input is differential amplifier which may be made of BJT or FET. An ideal op-amp, we assumed that no current is drawn from the input terminals. The base currents entering into the inverting or non-inverting terminals can be represented as current IB minus and IB plus respectively. Even though both the transistors are identical, IB and minus and IB plus are not exactly equal due to internal imbalance between the two inputs. So this is the structure of circuit diagram of input bias current. You can see this is input bias current, inverting amplifier with bias current. So here we can define the output voltage should also be V0 is equal to 0. And we find that the output voltage is offset by VA is equal to IB, etc. Right? So the average value of the two currents flowing into the op-amp of the input terminal is called input bias current IB, and the two input currents are identical due to mismatch in the transistors. Let IB1 be the current flowing into a non-inverting terminal and IB2 be the current into the other terminal. Then the input current is given by IB is equal to IB1 plus IB2 by 2. So the next one is input offset current. So the output stage of the op-amp is dual input differential amplifier. The input currents of op-amp or the base currents of the comparators used in input stage, transistors used in input stage. This transistor mismatch these current while mismatching differs. The algebraic difference between the currents flowing into the two input terminals of the op-amp is called input offset current and denoted as IIOS, input offset current, is equal to IB1 minus IB2. So this is the circuit diagram of input offset current. You can calculate resistance like feedback resistance into 2R1. So you can see the circuit of input offset current. So the next one is input offset voltage. The input offset voltage is the differential voltage which is required differently between the two terminals of the op-amp such that the output of the op-amp will become 0 when no input will be allowed to the op-amp. Output offset voltage is the multiplication of DC gain and the input offset voltage. So this is the circuit diagram of an input offset voltage, inverting amplifier, and equivalent circuit for the inverting amplifier. And the last DC characteristic is thermal drift. The thermal drift is the changes in the normal operational behavior of a device due to changes in ambient temperature caused by internal heating of equipment during normal transition or by changes in external ambient temperatures. There are very few circuit techniques that can be used to minimize the effect of drift. Careful printed circuit board layout must be equal which can be used to keep op-amps away from source of heat. Forced air cooling may be used to stabilize the ambient temperature. So these are all about the DC characteristics of op-amp. Thank you.